I think that's unmuted. One moment, guys. We're gonna. Second.
Crocs still in style. She literally asked me that when we were walking to class. I was like, I don't even wear Crocs, so I have no idea. Can't run.
Can't
Can't run.
So there is another homework online. I think this is the last assignment. Pretty sure. So it'll be due Monday. And we probably will spend some time Monday talking about it. And I think the last couple of classes will. I should have the final exam posted also by Monday. Earlier. So.
That's fair job.
And maybe. Now that I look, I don't know. Where?
Oh,
There you go.
nice. Oh my.
Yeah.
Thank you.
What?
Came out of nowhere.
There are a lot of mathematicians wandering around talking to themselves, but he's one of the more sane ones, actually.
So what's the ratio saying?
Sorry?
What's the ratio? Like normal people to crazy Einstein level mathematicians?
Yeah, most people are crazy. Most mathematicians also have some issues. I don't know. I assume it's sort of more larger density of issues with mathematicians, some correlation there. But I don't know. It's my experience. Anyway, so yeah, we'll spend the last couple of, I think, lectures just doing final exams. Questions. There'll be so many questions, right?
Wait, so then is the model gonna be like cumulative?
No, everything is taken on its own. Yeah. This is divided into modules. I mean, are you guys gonna remember all that stuff from graph theory? Yeah. Why would I tell you? What once was enough, right? It's different if it's like something like calculus, where you'll need to know it next semester, right? Like, you're not gonna need to know that. I mean, maybe you will, but
I have to take 3 calc. I'm scared.
this is more, this is a literacy type of course, right? You're supposed to have some exposure to stuff and not, you don't need to. Yeah, you know, like the difference between like fluency, like really understand, like you're literate in the ideas, like you have some kind of exposure to them. You're not,
Wait, what are we learning right now?
yeah, social stuff, social studies. Sharing, I told you, sharing,
Oh, yeah, with cookies.
cookies, donuts, whatever. I got a lot of donut stuff. Are still in the shop, no joke.
What's wrong with it? I feel like it's been in the shop.
It
for
needs a new
month.
engine.
Oh.
Well, I took it in, I thought it was just like a fuel line, and they said you need a new
What's
engine.
taking so long? Just like go to Google. Type in-
They've got one stall.
Are you sure that they're not just jipping you out of your money?
I'm not sure that they're not chipping me.
He
out.
hopes they're not.
I did shop around, so they were recommended by their competitors, so that finally a vote. But anyway, sharing. Yeah, sharing is fun and sort of, this is really, I mean, this is math light for sure. This is not, we're not doing heavy stuff here. We're adding and things of that nature. So it's kind of fun. And actually, I think this is kind of practical. Like, I don't know. I've never had a situation where I've had to use these theories, but you might. Okay, so last time I kind of gave an overview, but it was right at the end. So let me just repeat the main points about this. Main language. So this is just vocab. We've got a certain setup. We've got some assets that we want to divide amongst people, which we'll call players. So this is assets. Things to be divided. Because you could think like if someone dies and you want to give their stuff away, family or whatever. You have players. Again, these guys we denoted P1 through Pn, like in the previous chapters. So this is a little more, at least in, when you first look at it, it's a little complicated. It's the value. So given any subset, so I'll just say I think it is a part of the assets. There's a value for every given player. And it's not necessarily the same. That's the important thing. If it's the same for every given player, then it's easy. You just divide everything equally. Take all your assets. It's different though, then it becomes a little more tricky. And then what we're going to study is this thing called the fair division method, which there are a few. Okay. And then what are our assumptions? So we have some key assumptions that go into this, and we talked about them last time. Review this quickly. So we have this rationality assumption, which is never satisfied in real life, but it's kind of, you can kind of see remnants of it. And that's that, people will make logical choices to maximize their own gains, essentially. I won't. There's this notion of cooperation, which I still find a little strange. But it just means that people are going to follow the rules. There's no like back channels or anything like that. And also that there's somehow in cooperation means that the whole process for the fair division method has to be finite, has to end in finite steps. Privacy is a big one. Also almost never satisfied, where a player doesn't know other players' value systems. You're not, it's like everyone's sort of anonymous. And the reason for that is that if they have knowledge, then you can imagine they're sort of playing the game themselves rather than just sort of trying to make things mean, they can play the game, but having special knowledge is, it makes it, I would say, the whole, that's a more advanced course, let's say. Game theory kind of course. And then symmetry is sort of an egalitarian type of an assumption. I mean, it really means just that every player is entitled to, you know, their share. Their share to 1 over n. Yes. Their n as judged by their own value system. That's all very abstract, I would say. So what we want to do is kind of give a few methods. Which we still have. So there are 2 more, which are really, these are not, 2 more sort of vocab things, and we'll get started. All this language will make more sense when we do some examples. 2. One is this fair share. What is fair share? This is also referred to as the proportional fair share to P. This is an amount, not an amount, portion of the assets which player P deems their P values at greater than or equal to 1 over n. So 1 is 100%. So this is 1 over n percentage wise. That's a proportional fair share, 2p. So it's always 2p. So it's everything is relative to a given player. That's how we're. Then a fair division. What we're trying to get when we look at these fair division methods is we're saying fair division is an assignment. Portions. Really partition of the assets. S1 through Sn. So that Si is a fair share. Okay, that's the language. Now we're going to do some examples. Yep. Done. You have a question, please?
Yeah.
Ask away.
What's with this 1 over
N is the number of players.
n?
So right now we have 7, it's 8, of 8 students in the class. So if I brought in, well, this is a basic, let's say I brought in all the same kind of donut. And you all had the same opinion on that donut, valued it equally. What's going on? These are freaking me out.
That scares me.
Then if you valued it at that amount, then yeah, then we would want, you'd each want 1/8 of the donuts.
Of 1 donut?
Of the donuts.
Oh.
I brought in a big thing of donuts. You say, what is the value of that whole thing? Well, they're all the same donuts, so it's not like you're valuing different donuts at different. You don't have a preference, they're all the same time.
So then does it get
So you would
harder
all
when you have
want, you would all
preferences?
want 1/8, huh?
Does it get harder when you have preferences?
A little,
Oh, are
not
you
a
allowed
lot.
to get into
Yeah.
that?
Kidding. It's not that hard. It looks, right at this stage, it looks a lot harder than it is. And then we'll see that actually it's not that hard. It's kind of, there are some methods that make it kind of easy. And I mentioned one.
I bet you said that about the last
Everything's easy. Everything's easy.
one. Oh, wait,
No,
no.
go back up.
What?
No, just to the fair division. I'm not done.
Is that S1? Is a fair?
S1 is like the share.
Is a fair share?
Yeah, SI is a fair share to PI. So each player for each I.
Oh, the I means.
Well, we're just running through all of them for each I between 1 and each player. Does that sound good? Each of you gets 1/8 at least. Right? Okay.
How's your
Right? It's great. It was fantastic.
You know, I really feel like sharing today.
Right. Wow. Speaking of that,
So let's share donuts, shall we?
now I really owe you guys. Are they all the same kind?
They are.
You could have to like do a practical here.
Wow.
Jeez, what is that one?
How does this? What is that red one?
Red velvet.
Wow. All right, guys. By all means, help yourselves.
You know how awkward that was?
That was great. You guys are the best.
No.
Now I really have to bring in donuts separately.
What was Austin saying? Did the person get lost?
Yeah. No.
Was this like a delivery?
It was
Yeah.
DoorDash.
Oh,
Uh,
DoorDash.
We're like, put it on screens, but instead of very eyes, like, let's see.
All right. So for those of you at home, donuts just came in and you're missing out.
I hate stuff.
You hate stuffed donuts?
No,
Okay,
it
so
does.
where would you value,
Thank you.
what would your value on donuts be for better stuff?
Literally zero.
Zero.
Nothing. Because
Totally
they're
reasonable.
gross.
Because they're gross to you. Now, not to others, not to others, but to you. Exactly, but that's, so that's a good example, and we'll look at some examples here. So in fact, I have one I made up,
Well, not.
which is donut related. Okay, you guys are. All right, so I used the donut types that we had in our survey. Chocolate sprinkles. And I took a survey of myself and my 2 kids. Names are Birdie and they're cool kids. Most of the time. And I valued roughly this. Now I'll change this later because I want different examples. But okay. So basically the percentages I'm going to put are the percentages out of 100%, my relative value per donut. Imagine I have one of each of these. This is the rate. This is how they were, I sort of moved the numbers around a little bit based on that. They said a little more than this than equal, a little less than. All right. So now we can we could draw lots. That's the first example they give as a method to divide something up, where you can sort of like draw lots of choosing first, choosing second, and choosing third, right? And so in that example, to try draw lots, some method. Drawing straw. Person that draws whatever straw goes first, longest straw goes first, or shortest, and so on and so forth. But the problem with that is, so let's give an example where that happens. Base table here. So if I did that, okay, so let's say I drew first. So drew straws, and Dad goes first. And Jude. Okay, well, in that case, I go first, and for some reason today I just choose glazed. And then Judah goes next, and he decides out of the two he likes, he's going to choose sprinkles. And then Birdie goes to the remaining box, and her only option left is to choose chocolate, right? The others have been already half eaten. So if we're in that situation, then you can see chocolate's 31%. That she values it at 31%, which is less than a third, right? Strictly less than a third. So this is not a fair division, according to our definition. Because even though chocolate for me is worth 40%, for her, it's only, it's really to the individual that's getting it that matters. So this drawing lots, given an instant where drawing lots, I get more than a third of the value. My son gets more than a third of the value, but my daughter gets gypped. So what? Is it bad? It almost never happens. No, it happens all the time, but it's an accident, right? So, so this is no good. So this is not a fair division. This. And the point is that to be a fair division method, you have to be successful all the time if it's possible. So if it's possible to succeed, the fair division method has to 100% of the time succeed in giving a fair division. Otherwise, it's not a fair division. Let's write that down. Must always produce division if possible. So there's cases where it's not always possible, but I would say those cases are in this sort of discrete fair division category. So let me just mention that really quickly. And then so there's two types. Well, there's three types, but okay, I'll say there are two main types of games here. One, assets can be subdivided. Assets can be divided, let's say. I'll say can be subdivided. So donuts is a good example, right? One easy thing to do in this case would be we could take each donut and I could divide each donut into 3 parts equally and give each third to everyone. And that would, no matter what their value system is, that would divide things up fairly.
We have a glazed one for you, so.
I'm going for it. But if I do that, I'll get a glazed donut all over my eye. Messy. So assets can be subdivided. That's one thing. And this is sort of a continuous situation. It's continuous. The other case would be they can't. So cannot. Subdivided. And then this is what we'll call a discrete. So an example there would be, you know, let's say you had 3 cars you're dividing amongst people. Then really, you know, you're not going to chop up a car.
Shared time.
Very nice. But you know, you live in different states, so you don't really like each other. Want to
Mail it
share?
back and forth.
Huh?
Mail it back and forth.
Mail it. It sounds like a hassle. Let's just divide it. Let's find a fair division. If possible. However, when you earn a discrete case, it is possible that you cannot, there's no fair division. Like if everyone values the Porsche at like, you know, 90%, and you know, the Civic, it's 2 other Civics that are 20 years old, you know, 5%, it's going to be hard to divide that up without doing something. But that's what you're suggesting is sort of a violation of one of these sort of cooperation rules, where sort of the rules of the game, everyone's going to follow. We're not going to like invent new rules. Exactly. Although that's what you would want to do, probably. Okay. So, what to do? What to do? So we're going to look at the first method that actually produces a solution. This is what I talked about last time. This is this divider choice or divider choose method. Sort of the ancient Neanderthal. So, and this is really only for 2 players. So only when there are 2 players that we're going to look at this. We'll generalize it in the next sections.
Does that say 2-player queue?
Case. There's a Q there. Let's see. Case. Better? I can't. What? All right. So here's the method. Very simple. It's a very simple method. So P1 or whichever player you decide. But let's just start with, let's say P1. Divides assets. So this is a case where it's continuous. You're allowed to divide assets in this set. Divides assets into 2 groups. Groups A and B. And P2 chooses A or B. Done. That's the method. Real simple. The idea is that if this respects sort of rationality and privacy, then this will be a fair division method. And the point is that P1's rational and doesn't know what P2 likes, doesn't like the privacy thing, then P1 will divide it up evenly. Right? P1 divides it up unevenly. P1 is leaving open a strong possibility that they will not get a fair share. So P1 does not do that. P1 divides it up evenly so that each lot A and B, each group is worth 50% to P1. And now P2 has the value of A and the value of B. They add up to 100. One of them's got to be more than 50 or 50 or more to player 2. So they'll choose that one. And they both get fair share. Make sense? Okay, good. Let's do. There's a lot of words, but I'm not going to If it doesn't make sense, people should ask a question. It's a cookie example I gave last time. Right. It's funny, Shannon.
Cookies are next.
Huh?
Cookies are next.
Cookies are next? Are they coming?
That sounds
Zombie
like
It's terrifying. It's okay.
Zombie cookies are good.
Zombie cookies?
Insomnia.
Insomnia. Yeah,
Zombie.
they had that in Chicago. All right. So let's look at my example and we'll just take Judah out of the game. So he doesn't deserve it. It's acting up.
That's what he told me. I got
You don't
notes.
want your son in fourth grade
I
for-
love my son no matter what. It's just. It's acting up.
Right.
What grades are they?
My son is 12. He's in grade 7.
I'm so sorry.
It's rough. It's rough.
That's understandable.
The worst. Used to be such a sweet kid.
My nephew's 13 and every time he says something, I just like want to smack him sometimes. It's so rude.
Yeah, it's legal still. We looked it up. We can smack kids. We tried to let him know that.
He's not my kid, so.
And we don't do that kind of stuff. I didn't grow up in a smacky family.
My mom still smacks him.
I did, and look how I turned out.
He's just rude to everyone, so it just makes me want to like slap.
We're like the Swedish, like the Norwegian, like the Scandinavians don't beat their children. So we try not to follow that. model.
Real Americans do.
Yeah, we're not real Americans. They're pretty delightful when they're not. Anyway,
That's good.
so, okay, so here are the values are still the same. I just, put my son in timeout. And so now it's like we've got 3 donuts and I've got to divide them up. Or I've got to find a fair division for myself and my daughter. So what I'm player 1 here. And what I'm going to do is I'm going to divide them up in a reasonable way because I'm still pretty interested in eating donuts and the ones I like. So I have a lot of different ways I can do that. But I will do it in the following way. I will. So I'm going to break this up into group A and B. My group A, I'm going to have 1 chocolate, and I'm just going to cut the sprinkles in half. And my group B, I'm going to have 1 glaze, while the other half of the sprinkles will be in group B. And I make 2 pots, like I put, let's say 2 plates. Okay. So for me, because chocolate's worth 40 and sprinkles is worth 20, when I cut sprinkles in half, I have 10%. So I add those together, I get 50% here and the other 50% here. So for me, these 2 plates are equally valued, right? They don't, no difference. I'm happy with either. For my daughter, well, her sprinkles are worth 35%. So half of that is 17.5. And she's going to add that to the value of the chocolate for group A. So that will be 38.5, 48.5, pardon me. And whereas if she adds the half of the glazed, she'll get 51.5. So it's her choice. I did the division. It's her choice. And so she'll choose, and she will presumably choose B. She's rational. Almost all the time. She'll choose B.
I'll change it in a few years.
Yeah. Once she gets to be 12, I'm sure that will change. So Bertie chooses B. Now, that means that I get A. just write it out. Like sprinkles. Okay, now the thing to recognize about this setting, though I think maybe it's pretty clear how this works. But maybe one thing to recognize about the system is that things might have changed if my daughter had acted up, which also happens occasionally. And my son was. So let's say we did the same thing, but I took Judah, so he's 35, 35, 30. Let's say, oops. So one thing to recognize is if I did this exercise, but now I'm the divider, so I split it up in the same way, say, because it's still 50-50 to me. But now I have to recalculate the percentage for Judah. You guys can help me. So what would the percentages be for Jude? What do you guys say? For group A. Well, so what am I doing? I'm taking my one sprinkled donut, I'm cutting it in half, and I'm putting it on plate A with chocolate. So for me, that's 1/2 the sprinkles, which is 10 plus 40. That's what gives me 50. So what would it be for that single, for this plate? What would Judah value that plate at? 52.5 is correct. Half of 35 is 17.5, and I added to 35. And then that leaves 47.5 for plate B. So Judah would then choose plate A, leaving me with plate B. So I bring that example up because I want to say, of course, how this goes, even if I do the exact same thing as the divider, will very much depend on who the other person is. Right? Their value system comes into play. How they value things that may change the outcome for me.
So then the divider always wants to try and get something.
They because of privacy, they don't really have any idea of what the other person values. So they don't want to take the risk of getting less than 50%. And a fair division method, everyone has to get their fair share. And so fair share is measured at least, they're 1/n. So there's 2 here, so 100/2 is 50%. Okay. So one thing to learn is that 2. Let's remember. 1. This depends. Actually, a couple of things: the division and a value. Say player 2. That's something to know. So without looking at that, you're not going to get a reasonable answer. But 2, and this is the more important kind of lesson here, is that if you look at both of these instances, the advantage goes to player 2. It's like goes to chooser. Right? Birdie got 51.5%. I got 50. Judah got 52.5%. I got 50. Because I as the divider need to make sure I divide it really evenly according to my value system so that I don't get gypped. But then the chooser has options in general, and they can maximize their individual value. So that will always choose to be the chooser if you have that choice. There's a lesson there. And this persists in the other methods, sort of the generalizations. Questions? Okay, guys. So this is a pretty basic, straightforward thing. And now we want to generalize this to more than 2 players. So the lone divider method. I'm going to extend divider choice. Choose to more than 2 players. Okay. So we'll start with n equaling 3. So subcase. It's okay. Yeah, you're right.
I don't know if I can change.
All right, all right. Okay, n equaling 3. So in the lone divider method, there's one divider. One divider. It's a player. And we'll call that player the 2 choosers. We'll call C1 and C2. The 3 players. And we're going to give the method that we have for getting a fair division. This again is a continuous setup, so we're allowed to take our assets and subdivide them. All right, so what's the first step? Step 1 is the divider, D, divides assets into 3 shares. We'll denote S1, S2, and S3. These are like the plates. But now we're going to these divided into 3. So note, so these are going to be divided up to the other players, and then one to player D. However, so from the same logic as before, to D should value S1, S2, and S3 equal. He's going to get one of them. She's going to get one of them. So that's by privacy and finality again, they should be valued the same. 2-player D. Equally valued by. So now step 2, this is where the plot thickens a little bit. This is called bidding. So C1 and C2, these other 2 players, write down privately which shares value, we should say are fair, but we'll just say have value greater than or equal to 1/3 fair shares. Then to their value system.
What if they both pick the same.
This is just a step. They're just writing them down. We'll get there. We're not done. It's not over. So now we have we're gonna have two different kind of we're gonna have two different types of shares.
That's construction.
Sorry. So a C, oops. So S1, 2, S3, then are one of two types. Let's see. Are of one of two types. Either C for chosen by C1, or they can be chosen by either players, C1 and C2, or C2. They don't have to be chosen by both. Or a U unwanted. So in other words, they're not chosen by either.
Unwanted. Oh.
Hey, what was the Phil donut, right?
It's still wanted by the divider. It's not wanted by me.
It's just by C1 and C2. This is just according to the lists. C1 and C2. It's not sad because, yay, if that share is still a third to the divider, that's great. The problem is if two shares are only one is in this case, then you have to
I don't know this class.
deal with it. Huh?
Whoa.
This class, I still have to get it.
Ouch. Jeez. So step 3 is the last step. This is distribution. And here we have to look at the case. So distribution, two different cases. There are two possibilities. We'll do examples of this next time, but I'll just describe it. Two possibilities. One, there are two more type C chosen, I'll just say chosen shares. So if that's the case, you can take those two and give them to players C1 and C2, and then give the remaining share to the divider, and it will be a fair distribution. In this case, give C1 2 shares from their list, their respective lists, and a remaining share to the advisor. Now, on the other hand, it could happen that only one share is chosen. Now, there can't be no shares. There could be only one. Now, what do you do? No, that's not going to produce a fair division. So what you do is you give, so here, give the divider one of the unwanted shares. Not unwanted to the divider, but to the other two. Doesn't matter which one. Then join the remaining shares. And have C1 and C2 use fair division. Or choice, sorry, divider choice. Divider choose. With those shares. Point is, let's make this verbally. Point is that those two shares to both C1 and C2 account for more than 2/3 of the value. So the divider choice method will work to produce a fair division. Okay, we'll give some examples of that next time. Thank you guys for the donuts. It's very sweet. I feel like I owe you. There still will be donuts. Okay, well, help yourself.